Okay, good morning to all of you. In our last class, we have been discussed in detail about hypergeometric distribution, whose PMF we found mcx n minus m c n minus x by ncn, where your capital N is your belongs to your total value, and m is a positive integer which is less than that of the capital N, and n is the positive integer is at most n, which can be at most n. Okay, in detail we have been discussed, and we discussed the proof of the PMF, and we determined its first moment, that is your small n m by n, and second moment mu 2 dash is this much, and with the help of first and second moment we evaluated the variance is your this one, and how it will be approximation to binomial in which condition, that also we have been discussed in detail. Okay, in today class we are going to be discuss, uh, actually we decided that we have to discuss multinomial distribution, but before that we are going to discuss the moment generating function, that is your m.g.f of hypergeometric distribution, and few numericals based upon hypergeometric distribution. Okay, so let's start. We know in general moment generating function, we know in general mgf 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 is mxt equal to expectation of e to the power tx, right? So here we know that the expectation of any value will be summation over 0 to n e to the power tx into the PMF, that already we have been discussed. You can refer the previous video. And here what I done, that e to the power tx I expanded like that, because we know that the expansion of e to the power x is nothing but 1 plus x by 1 factorial plus x by 2 factorial and so on, x square by 2 factorial plus x cube by 3 factorial and so on. This expansion here also we have been considered, that here it is x only, here it is tx. Okay, tx, so it will be 1 plus tx by 1 factorial, t square x square by 2 factorial, t q x q by 3 factorial and so on, into this m PMF, probability mass function. Okay, so here what I done, that this PMF I have been multiplied with each term, this first term, second term, third term, fourth term and so on. Here we intend to find out only the expectation value and ex square. Here we are intend to find out the variance. For the variance we need only mu 1 dash and mu 2 dash. Okay, that means expectation of x, expectation of x square we need to find out the variance. So no need the considering the higher order of x. So higher orders of x I have been not considered. Here you can see that here this term has been multiplied with 1. We found 1 into this one, plus summation over x equal to 0 to n, x equal to 0 to n, x here t x by 1 factorial, here t by 1 factorial taken outside, x into this much, this one t square x square by 2 factorial, so t square by 2 factorial taken outside, because summation is on the x, so t square or t terms taken outside, t square by 2 factorial, here x 0 to n summation x square and this PMF. Okay, as I told that we intend to find out only x and x square, I not taken the higher order of x, xq x4 I not taken here. Okay, may you can take for the to find out the higher order moments. Okay, I need only first moment and second moment. Okay, so here you can see this will be, this is nothing but the PMF, and summation over 0 to n the PMF will be nothing but 1. Already we have been proved, so I have been written directly 1. Okay, so here t by 1 factorial into here I straightly written n m by n, because this value already we found previously in our previous video. You can check. So in detail, how, see this value x into this one, here is the same x into this one. Okay, so this value we found n capital M by n, okay, by using Vandermon's identity. So the proof of the Vandermon's identity separately I will give you separate video, but here you can see that by using Vandermon's identity we have been found that first moment or ex, or the value of x into this much, is nothing but your n m by n. Already we have been evaluated, so directly I have been substituted that n m by n. Then t square by 2 factorial and this much value also we have been evaluated previous in a previous video or previous lecture, that x square summation over 0 to n x square into this much we found same by using Vandermon's identity, and by considering the different notations at the time of derivation, we found m into m minus 1 into n minus 1, n into n minus 1 plus nm by n. Already we found that value. Here I substituted, okay, and so on. Here I am going to suggest one thing, that suppose in your exam it is asked that you have to find out the mean and variance. Suppose in your exam you are going to find out mean, that is your ex, or first moment, and ex square, that is your second moment, from which by using this you can find out the variance, that we know that ex square minus ex whole square, that we know. So these two value if we found, then we can easily find out the variance, right? So suppose in your exam it has been asked that you have to find out the expectation value and variance. So you have to find out the ex and ex square, right? So at that time, you can consider either this method, that means you have to find out the first moment and second moment, whatever we have been done in our last video. You can consider that method, or you can consider the moment generating function. So here, whenever you are going to consider moment generating function, here as we have derived the summation value, this summation's value we have been already derived here. This one we have already derived this one, but only for that I have been directly written. But in your exam, if you are trying to find out this one, or ex, or first moment and second moment using moment generating function, here you have to evaluate this summation. The procedure how to evaluate, last video we have been discussed. So here it has been written, see, summation of 0 to n, this much value is this much. Here we have been evaluated. So if in your exam you are trying to find out expectation and variance by using moment generating function, this summation you have to calculate in your exam paper, okay? That means what I am telling, that instead of writing the value this much equal to this, you have to derive the value of this one is this, how it will be, whatever we have been discussed in our previous video, okay? Similarly, here I have been substituted this value will be this much, whatever we have been evaluated step by step in our last lecture. So if you are trying to find out the expectation and variance with this method, moment generating function, also you have to evaluate this value will be this much. That means you have to consider all the steps whatever we have been discussed here in our last video. So simply you should not be write this value will be this much, okay? Here you have to write all the steps. Here I have been omitted those steps, or not written those steps, because already we have been discussed in our previous video, right? So after substituting the value of this equal to nm by n and this equal to here, we found mxt. mxt equal to 1 plus t by 1 factorial into n m by n plus t square by 2 factorial, this much plus so on. And higher order term I not considered here, as I am concentrating upon one first and second moment. Okay, so finding the moments and variance from m.g.f, moment generating function, we know that the coefficient of t by 1 factorial, previously we have been discussed in our class, in our offline class, that the coefficient of t by 1 factorial, that is nothing but your mean expectation value, that is your first moment mu1 dash, how much, n m by n. Okay, and coefficient of t square by 2 factorial is nothing but second moment, that is your ex square 2 dash, that is your m into m minus 1 n into n minus 1 by capital N into capital N minus 1 plus small n m by n. Okay, the same thing we found deriving in this way also. Either method you can use by to find out the moments from m.g.f, that the rth moment, we know that rth moment is rth derivative of moment generating function at t equal to 0. So first moment, if we want to find out, that means first derivative of moment generating function at t equal to 0. So this is your expression of your moment generating function. Now we have to consider the first derivative of this one. The first derivative, if I am going to do, then it will be, see here t is 1, only t is there, this will be 2t by 2 factorial, right? See, the first term it will be 0, the second term derivative with respect to t, that means it will be 1 by 1 factorial itself 1, and here t with respect to t means it will be 1, so 1 n m by n by n, then here this will be 2t by 2 factorial and so on. Whatever the term, higher order term we are going to be consider, if you are going to be consider after this, those terms has to be contain the t term. Now if we are going to be put at t equal to 0, after derivative, after first derivative, if I am going to put t equal to 0, then except this term all the terms will be 0. Then what we found n m by n, that is your expectation, right? And if we are going to consider second moment, that means mu 2 1, that means we have to consider the second time derivative, or d square mxt by dt square at t equal to 0. So already we found the first derivative is this one. Again another derivative, if we are going to do, this term will be 0, it is constant, and this term will be 2 by 2 factorial will be 1, and derivative with respect to t it will be 1, and the next term whatever we have, that will be contain t term. So after derivative, if I will be put t equal to 0, then only I can get this term, that is your m into m minus 1 n into n minus 1 by n into n minus 1 plus n m by n, that is your second moment, which is your e capital X square. So here we found ex equal to this much, ex square equal to this much, whatever exactly same as we have been derived in our last video or last lecture. So by using ex square and ex, we can found the variance will be the same. Okay, so either way you can choose to find out your expectation and variance for this distribution, hypergeometric distribution. Now we have to go for the few numericals regarding hypergeometric distribution. So here this is the question, first question, that a box contains 50 light bulbs of which 5 are defective. So automatically non-defective are 50 minus 5, that means 45. Okay, so now a quality control inspector, what he done, he randomly selected 4 samples or 4 balls without replacement. This is most important. Let x equal to number of defect balls are selected. Find the PMF. This is one question. Then find probability from the 4 selected balls, 2 are defective. So before we have to do the numericals, whatever I have 6 numericals. So here I am going to be suggest you one thing, that you have to first segregate, or whenever you are reading the question, you have to read carefully and try to find out the value of n, m, small n and x. These are the most important, because pmf uh, of the hypergeometric distribution uh, is what? That is your mcx n minus mc n minus x divided by ncn. So here m, n, x and small n, if we can found in a question, then easily we can find out easily we can solve that question. So for that, here it is a easy tricks or method. Generally all the students are, all the peoples are adopting this technique or method, that here this n, capital N, is our total number of sample. Okay, so I selected n number of sample, right? This is your small n. So here from n, what we intend to find out, so without replacement, here some inspector trying to find out number of defective balls. So let x is your number of defective balls. So this side you just try to find out how many numbers of total numbers of defects are present in the total number of balls or samples. Okay, so here aim is nothing but your defects, as we discussed in our first lecture or first class, whenever we have been discussed hypergeometric distribution, that m balls, m of which are white, and what is the probability of getting white? X is white and m is your white. So here in this question you can find that what is the number, x number of defective, and 5 are defective. Okay, so here m, capital M, is nothing but 5. Okay, so here this side you just keep what you intend to find out, that is your x. Okay, and along this side you have to find out total number of this type from total number of sample. Again I am repeat this sentence. This side you keep what you intend to find out, and this side you have to find out, you have to write how many total numbers of this type are present inside the total number of sample. Okay, that is your m. So another type will be automatically n minus m. So if we intend to find out x, then rest will be n minus x. Okay, so this type of diagram, if you can draw after reading the question, it will be easy for you to solve the question. Okay, so for this question exactly, what is the n? That means total number of light balls are 50. So we intend to find out the defective balls. How many numbers I have been, the inspector has been drawn? 4 samples selected, or 4 sample has been drawn from the 50 light balls. So from the 50 total number of 50 balls, he has been drawn 4. So here small n equal to 4, here capital N is equal to 50. So here x is the defective, belongs to defective. So we have to write total number of defective balls this side inside the total number of balls. So in the question, how many total number of defectives? 5. 5 are total number of defectives. So here I written 5. So this 5 is represents capital M. So obviously 50 minus 5 means 45 is belongs to your n minus m. Okay, so this is nothing but rest of the samples after considering the defects. So this will be n minus x. So the corresponding PMF, whatever given in the question, will be 5cx. You can see mcx here, 5cx into n minus m is your 45. 45c n 45c n minus x, 45c 4 minus x, and here total c how many the inspector has been drawn, 4, 50c 4. Okay, so this will be the required PMF of this question. Now if this is another question, that then find the probability from the 4 selected balls, 2 are defective. Exactly 2 are defective. That means here instead of x we have to write down how much, 2. So if I am going to write the 2, then the answer of this question will be how much? So here instead of x we have to write 2, and this will be 4 minus 2 will be 2. So 5c2 into 44c2 by 50c2, you just calculate the answer. Okay, this will be the required answer. Next we have to go for the another question. Suppose a bag contains 100 items. So here this is represents total n. I have been written total 100, 5 of which do not conform to requirement. Here you just read separately or segregate the question, it will be better for you. So this is the total number I have been written. So 5 of which not conform, belongs to not conform. 10 items are selected. So from this 100 how many has been selected? 10. So small n will be equal to 10. So without replacement, which is most important. See, without replacement is most important. Whenever it is written that without replacement, it is only this problem will be solved by using hypergeometric distribution. So if it is written with replacement, then it will be go for the multinomial distribution, whatever we are going to discuss in our next class. Okay, so without replacement, then the probability of finding 2 items are not conforming sample. So here 5s are not conforming. So we intend to find out the probability of not conforming samples. So here this side we have to write the what we intend to find out. This is belongs to not conforming from the 10 items. So here this side we have to write down the not conforming samples from the total. From the total, how many not conforming? 5 I have written. So conforming how much? 100 minus 5, 95. Here from the 10, 2 are not conforming, rest are 10 minus 2 equal to 8. So probability x equal to 2 will be 5c2 into 95c8 divided by 100c10. Okay, you just calculate what will the answer. That will be the final one. Okay, next one is your, suppose a shipment of 10 DVD players is known as to have 10 defective players. An inspector randomly choose 12 for inspection without replacement. This is written without replacement. He is interested in determining the probability that among the 12 players at most 2 are defective. Here at most 2 are defective means if there is no defective also it can be acceptable. That means x equal 0 can be acceptable, x equal 1 if 1 defective also it will be acceptable, if x equal 2 also it will be acceptable. So for x equal 0 we have to consider 1, 2, these 3 possibilities also all are to be considered. So what is the total number of DVD? 100. Okay, so here inspector intend to find out are defective. So how many samples has been drawn from this 100? 12. So I have been drawn 12. Okay, now how here inspector intend to find out the defective. So here this side I have to consider the defectives, x equal to maybe 0, 1, 2. Okay, so if this side is defective we are going to be consider. So from 100 how many total number of defectives? Total number of defectives are 10. So I written 10. So here if x equal 0 will be defective, the rest will be n minus x, that means 12 minus 0 will be 12. If x equal to 1, then 12 minus 1 will be 11. If x will be 2, 12 minus 2 will be 10. So these are belongs to n minus x. Okay, as these all the three can be considered. So for x equal to 0, this will be 12. So what will be the probability? 10c0, from 10 0 will be defective, 10c0 into non-defective is 90, 90c12, 90c12 whole divided by from 100 12 has been considered, 100c12, again plus, as 3 will be possible. Okay, so here if 10c plus 10c1 into 90c11, 12 minus 1 11, 11 divided by 100 c2. Likewise, x equal to, for x equal to, this will be 10 c2 into 90 c10, 90 c10 divided by 100 c2. You just calculate, you just add these 3 and find out the final answer. Okay, we have to go for the next question. Next question is this one. This question is easy one. Consider Vidya, one student, draws 3 cards from a pack of 52 cards without replacement. Okay, what is the probability of getting no kings? No kings. So 52 cards, how many he has been drawn? He has been drawn 3. So small n equal to 3, capital N equal to 50. So here what we intend to find out? No kings. No kings means x equal to 0. So how many? So first here we have to find out, here this side we have to write how many kings are there in 52 cards. Okay, here we intend to find out kings. Okay, no kings or one king or two king, like that. So here how many kings are present in the 52 cards? 4 kings. Okay, so excluding 4 kings, no king cards are 48. So we intend to find out for x equal to 0 means no king, then this will be n minus x will be 3. So what will the answer? 3c0, 3nc0. So here I mistakenly written 3c0 to 4c0. From 4 kings, no kings has to be selected. So 4c0 into no kings will be 48. From the 48, all the 3 cards have to be drawn. The 48c3 divided by 52c3. So 4c0 will be nothing but 1, and 48c3 is 48 factorial by 3 factorial into 45 factorial, and 52c3 52 factorial by 3 factorial into 49 factorial. You just calculate and find the final answer. Okay, we have to go for the next question. A group of 10 individuals are used for a biological case with the following blood groups. Type 1 belongs to 3 peoples, type 2 belongs to 4 peoples, type 3 belongs to 3 peoples. So here how many total numbers? There are 10. 10 are the total numbers, that is your 10. This is somewhat different questions whatever we have been discussed 8. Total numbers are 10. So type 1, here how many drawn? We have how many samples randomly selected? 5 randomly selected. So 5 samples has been randomly selected, n equal to 5. Okay, so from this 10, how many types we have? How many types? Type 0, 3 people. So this is belongs to, suppose type 0 is 3, and type 1 type A, sorry type O, this is O, type O, blood group type O, 3 peoples, and type A belongs to 4, and type B, type B are 3. So here you can see that 4 plus 3 plus 3 equal 10. Okay, so now we drawn the 5 portions, or we consider the 5 portions randomly from the 10 portions having 0 blood group 3, A blood group 4, B blood group 3, that we have to find out the what will the probability that from that 5 persons type 0 type 0 type 0 will be the 1, type A will be the 2, and type B will be equal to 2 2 2 1 5. Okay, so what will be the probability? It is exactly similar what we have been already discussed. So first to divided by what we have to write 10c5. Okay, from the 10 we considered or we are randomly selected 5 elements or 5 persons, right? So here type 0, type O will be 1. After selection type O will be 1 from how many? From 3. So here we have to write 3c1 into type A will be 2 belong from 4. So 4c2 into these 2 type B whatever we have been selected, that will be come from the total numbers are 3. Type B persons or peoples are 3. From 3 these 2 has been selected, so we have to write 3c2. You just calculate it and find the final answer. Okay, now we have to go for the last question. This is your last. So this is your last question, that find the expectation of hypergeometric distributions or that probability that a 4 trial hypergeometric experiment results in exact 2 successes when the population consists of 16 items. So here total number has been given how much? 16, right? So from n equal to 16 we have been considered small n. How many trials we have been done here? N equal to 4. See, here in the question it has been given that we have to find out the expectation of hypergeometric distribution. So expectation of hypergeometric distribution is nothing but small n capital M by capital N. So here capital N has been given 16, small n has been given 4. And here in the question it has been given that among the 4 trials experiment exactly 2 successes. So here from this n equal to 4, x equal to 2 has been given successes. So total successes from n equal to how much it has been not given. So here arbitrarily we can consider m equal to m, that is your total success in your n. Among 16 total successes, anything as it is not given, let this is your m. So expectation value will be how much? That will be n equal to 4 into m by 16. So this will be m by 4. Okay, so if in your question it has been given m value, suppose m value has been given 3. So expectation value will be 3 by 4. Suppose m will be 8. Among 16, 8 will be total successes. So the expectation value will be how much? It will be 8 by 4 equal to 2. Okay, so as it is not given how many total number of success in total number of total populations, so we can consider m. Let m is your total number of successes, among which whenever we are going to be 4 trials, in the 4 trial exactly 2 successes we found. So here x has been given capital n small n, m is not given, but expectation is your n capital M by n. So for this question the expectation value will be this much. So thank you so much for watching this one. Now watch carefully, write down the note perfectly and ready for the next class, and we are going to start to discuss in our next class multinomial distribution. So thank you so much for watching this video. Thank you.